to the basics of quadratic equations. So when we're talking about quadratic equations, the thing we need to start with, what is a quadratic equation? So a quadratic equation is just an equation that has an x squared term in it. So an example would be like y equals 5x squared plus 2x minus 6, or um, 2 equals x squared plus 4x minus 8. Okay, it's just an equation that has an x squared in it. Okay, that's all it means to be a quadratic equation. We have what's called a standard form for a quadratic equation. It looks like this. All of our x terms are on one side, so x squared plus bx plus c. We have a y, or just another number, on the other side of the equal sign. This should look familiar to you. When we were talking about factoring trinomials, our trinomials look like this: ax squared plus bx plus c. It's the same thing, except now we've just putting in an equation, and we've got something else on the other side of that equation. So not too much different. The main thing we're going to focus on today are the graphs of quadratic equations. So we've got this vocabulary word you need to know: parabola. So a parabola is just the U-shaped graph of a quadratic equation. So quadratic equations always have this U-shaped curve. Instead of being a straight line, they're a curve. We call that curve a parabola. We've got two options for a quadratic equation. They can either open up, so we got our like smiley face U here, or they can open down, kind of frowny face, upside down U here. And what determines whether a quadratic opens up or down is that leading coefficient, that a, your first number out front. Okay? If your leading coefficient, if a is a positive number, if it's bigger than 0, then your graph opens up. And if it's a negative number, if it's less than 0, then it opens down. So for example, this could be something like y equals x squared plus 6x plus 5, right? This is a positive leading coefficient. Maybe this one is something like y equals negative 2x squared plus 4x plus 8. Okay, this one has a negative number out front. That means it opens down. We're also going to talk about some other key features of quadratic graphs. These are kind of important. These are the main thrust of what we're going to be talking about in this lesson. So if I look at a quadratic equation, I've got 4 main features that I really want to focus on. The first one is the vertex. The vertex is the maximum or minimum. Okay, it is the highest or lowest point of a quadratic equation. Okay, a quadratic is either going to have a high point or a low point, depending on what it looks like. In this quadratic equation, you can see it has a lowest point down here. That's the vertex. For this problem, the vertex, we always write the coordinates as a coordinate pair. The vertex is at 1, negative 4. So we say our vertex is at 1, negative 4. Another key feature is the axis of symmetry. So hopefully you know what this word symmetry means. Symmetry means that if you cut a shape in half, one side is the mirror image of the other. The axis of symmetry is the line that kind of acts as that mirror. It cuts the shape in half. And the way you find it is that it is a vertical line that goes through the vertex. So we can see it's this dashed line here. And we always write it as x equals some number, and that number is the x-coordinate of your vertex. So in this case, our vertex was at 1, negative 4, so our axis of symmetry is at x equals 1. Not a particularly challenging thing to find. Just find your vertex. The axis of symmetry is just x equals whatever the x value of that vertex is. The y-intercept, just like with a linear equation, the y-intercept is where our graph, where the parabola crosses the x or the y-axis. So in this case, that is at the point 0, negative 3. X value will always be 0 on the y-intercept. And then possibly the most important of our key features is the x-intercept, or intercepts. There can be more than one in a quadratic equation. And you'll notice I have 4 words here: x-intercepts, roots, solutions, zeros. These all mean the same thing. They are interchangeable with each other. Okay, the x-intercepts, roots, solutions, zeros. And it's going to become really important when we talk about solving quadratic equations, because I want you to think about the fact that the x-intercepts and the solutions, intercepts, solutions, they're the same thing. Okay, so when we're solving, what we're really doing is we're finding the x-intercepts. It's just where the parabola crosses the x-axis. So they're always going to have y values of 0. If I look at this one is at -1, 0, and this one is at 3, 0. Okay, so really important to know, x-intercepts, solutions, they're the same thing. You're going to hear me saying that a lot in this unit. Okay, so let's look at an example. Let's identify the key features of this quadratic equation. So the first question is the leading coefficient of this quadratic positive or negative? So it says a, because we're talking about in standard form, y equals ax squared plus bx plus c. And so we're trying to figure out, is this a term a positive or negative number? And we do that just by looking at the graph. Okay, this one opens down. Okay, and because it opens down, that tells me our leading coefficient is a negative number. Okay, if it opened up, if it had our smiley face U, that would be a positive leading coefficient. What are the coordinates of the vertex? Okay, so remember, the vertex is either the highest or the lowest point. This one has a high point. Okay, and on this graph, looking at our scale, okay, this point right here is at 1, 4. So 1, 4 are the coordinates of our vertex. What's the equation of the axis of symmetry? Remember, it's always x equals whatever the x value of our vertex is. So x equals 1. Okay, our axis of symmetry is this dashed line that cuts the graph evenly in half. What are the coordinates of the y-intercept? So we look at our graph, we go, where does this cross the y-axis? Crosses it right there at 0, 3. Then it says, what are the coordinates of the roots? Okay, remember, the roots are the same thing as the x-intercepts. So I look at this and I go, okay, how many x-intercepts does it have? It has 2, one here, one here. This one is at -1, 0, and this one is at 3, 0. That's all there is to it. We're just looking at the graph and finding these key features. All right, so when it comes to the x-intercepts, when it comes to the solutions, you have 3 possible options. A quadratic equation can have one solution. So like in this graph, where it just comes down and just touches the graph and comes back up. 2 solutions, like this one, where it comes down, crosses the graph, crosses the x-axis, comes back up, crosses again. Or it can have absolutely no solution at all. It can have no x-intercepts, where it comes down and its vertex is before the x-axis and it just comes back up. So that's how many solutions we can have. Okay, we can either have 1, 2, or none. So if we look at this one, it says the equation y equals x squared plus 3x plus 10 is graphed below. How many solutions does it have, and what are their coordinates? So let's answer the first question. Okay, the number of solutions. Well, number of solutions, I look at my graph. Here's my x-axis. It crosses the x-axis 1, 2 times. So this one has 2 solutions. What are their coordinates? Let's see. This one is at 1, 2, -2, 0. And this one is at 5, 0. And that's it. Okay, so the idea here is we're just looking at this graph. We're going, how many times does it cross the x-axis? In this case, it's 2. What are the coordinates? -2, 0, and 5, 0. All right, and that's it for this video. So I'm going to leave you with this try it problem. Yeah, you need to answer each of these questions about the graph that we see here. Okay, so what's the leading coefficient? Is it positive or negative? What are the coordinates of the vertex? What's the equation of the axis of symmetry? What are the coordinates of the y-intercept? And what are the coordinates of the solutions? That's all there is to it. Give the try it a try.